Good morning, everyone. Today is August 19th, Tuesday. This is our final lesson for this course. We're doing a course review part 2. Your culminating will be due, is available. You can start on it today. I think you have until tomorrow to complete it. We'll double check that, but it shouldn't take you that long. So good luck on that. So I suggest everyone to complete it today. And if there's any questions about your marks or anything like that, come see me during office hours or, send me an email. But the best thing to do is probably come see me during class or office hours. Either stay late a little bit today or see you tomorrow in the morning and you can ask me questions. So tomorrow there isn't really a lesson. It's more office hours. So just come see me and then we can do a Q&A if there's any issues with anything. So yeah, let's start now. Course review part 2. Boom. Today's agenda. We're going to do our learning goals. We're going to go over quadratics, exponents, exponential relations, interest, financial applications, today's work, and then some questions. So what are some learning goals? We're going to solve problems relating to quadratic relations. We're going to solve problems relating to exponential relations, and then interest, simple and compound, and then we're going to describe the applications of interest in real life. Let's do some quadratics. Identifying a quadratic relation. So what or how do we do that? Well, one way is to look at the equation and look for the highest exponent that is on the variable x in this example. In this example, the equation, we have 3x squared. So 2 is the highest exponent. This is how you know it's a quadratic relation. If it was any other number than 2, it would not be a quadratic. So if you don't have an x squared term in your equation, now let's say you do have an x squared term, but then you also have an x to the power of 10 or x to the power of 5, any number bigger than 2. Well, that's not a quadratic. The biggest number possible has to be 2. As for the other two terms, it doesn't matter if they're there, if they are, or if they aren't. Regardless, it's a quadratic. So that's the easiest way to look at the equation. Look for that x squared term as the highest term possible. If you look at the graph looks like a U-shaped graph, a parabola. It can be opening up or opening down. It doesn't really matter, but that's a quadratic relation. And then the table, the way to look at the table is to look at your first differences and then your second differences. If the first differences are constants, it is considered a linear relation. If the second differences are constant, meaning the second differences are all the same number, then that is the definition of a quadratic relation. Here, let me show you an example of that here. So I'm going to do first differences and second differences. We've done this a few times now throughout this course. Hopefully you remember, and you should have done this in grade 9, you do first differences, and in grade 10 you do second differences. So hopefully, easy stuff. Always block out the first kind of block or area for your first differences, and then the 2 blocks for your second differences. So we're going to do minus 7 minus negative 17. And if you do that properly, that becomes negative 7 plus 17. So the answer is negative 10. Here we have negative 1 minus negative 7. So that's negative 1 plus 7, which is going to be positive 6. Here we have 1 minus -1. That's basically 1 plus 1, so you have 2. And here we have -1 minus 1, which is the same thing as -2. Now, second difference is we're going to do 6 minus 10, which is 6 plus 10, which is 16. 2 minus 6, which is -4. And -2 minus 2, which is -4. That leads me to believe that maybe I made a mistake somewhere. So let's see. -7 minus -17, right? This is going to be positive 10. See that right there? It's positive 10. And -1 is positive 6. So now, made a small mistake here. And this is why it's always important to go back and check your work. Very important lesson for students. They do something quickly, and then they just write the answer. They don't really review, see if they made any mistakes. Very important. 6 minus 10 is what should be written here. You have -4. And now you can see that all of these are the same. So this is a quadratic relation because second differences are all constant. All right, let's move on. Quadratic equations. There are 3 forms of a quadratic equation. We went over this in our class. Standard form, which is of the form y equals ax squared plus bx plus c. We have a vertex form, which is y equals ax minus h all squared and then plus k. And we got a factored form, y equals a and then brackets x minus r and then brackets x minus s. Now, excuse me. Each one of these forms tells us a piece of information or pieces of information about that quadratic relation. In standard form, when a is positive, the parabola is set to open up. When a is negative, the parabola is set to open down. So we know from the a value alone whether this parabola from this equation is opening up or down. We also know the c value corresponds to the y-intercept of the parabola. So we know one given point on this parabola, and that point is the y-intercept when it's written in standard form. And that's it for standard form. As for vertex form, we know a few pieces of information. We know that a indicates the stretch or compression factor of the parabola. Also, it's the same as the previous a value. Whether it's positive or negative, we know if it opens up or down. So your h value tells us the horizontal translation of the parabola. Your k is the vertical translation. Vertex is located at h, k. So your vertex is the point of the parabola that's either the highest point or the lowest point. It's kind of like the middle symmetrical point, the middle point of the parabola. And the coordinates are h and k, h being the x coordinate, k being the y coordinate. So from the vertex form, we know exactly one point as well, which is the vertex point. And then we also know the equation of the axis of symmetry, which is x is equal to h. This is just that dotted line. And yeah, it's that line of symmetry. For factored form, a once again tells us the direction of opening, up or down, and r and s gives us up to 2 possible points, and these are the x-intercepts. So each form of your quadratic equation gives you points. Depending on which form it is, then you get a different point. So standard form gives you the y-intercept. Vertex form gives us the vertex point. And the factored form gives us the x-intercepts. And they can be up to a maximum possible of 2. Doesn't mean there are 2. They can also be 1 x-intercept. Or they can also be 0, none. So we're very important to understand that quadratic equations do not have to have two x-intercepts always. We're going to graph some quadratics now. So the way to do that is to make a table of values, or you can use the transformation method. It doesn't really matter. I think for you guys, it's probably better just make a table of values. That's usually easier. All right, we got our x and y. Now, you should always pick 5 x values. And the way to decide what those 5 x values are, very simple. You look at your h value. That's always the first value. Now here, what is my h value? H is equal to what? I'm gonna ask the class. Got it, Krish. The answer is 3. Sir, remember your h value is the number that's inside that bracket, except it's not the sign that's inside that bracket. So if you see -3 here or -3, then your h value is +3. That's very important. You need to know that because that's the number that's going to go here in the middle. Then you choose from this starting point, you choose a point above it, +1, and another point above that. And then you choose a point below it, 2, and then 1, 2 points below. This is how you always graph your parabolas. Very easy. Just remember that starting point. Once you have that, we know our y value for this vertex point is going to be 1, 3, 1, because 1 is from here. It's our k value, h and k. As for the other y values, we need to figure this out. We need to plug in the x value into the equation and do the math. So if I plug in 4 here, 4 minus 3 is going to be 1. 1 squared is 1, and 1 plus 1 is 2. So the answer is 2 here. Then I'm going to plug in 5 into the equation and try to solve it again. 5 minus 3 is 2. 2 squared is 4. 4 plus 1 is 5. The answer is 5 here. Because this is a parabola and because the way we set this up correctly, you can double check your work. But I know because of symmetry that this has to be the same y value and this has to be the same y value. And if you don't believe me, just double check. It takes a second to plug this value in. Plug in 2. We have 2 here, 2. Plug it in. We have 2 minus 3. 2 minus 3 is -1. But remember, -1 times -1 is +1, and +1 plus 1 is 2. So that checks. This is 2. And if I plug in 1 into our equation, 1 minus 3 is -2. But -2 times -2 is +4. And 4 plus 1 is 5. So we know we did it right because these numbers are the same. 5 and 2, 2 and 5. Once you have that done, you just plot the points. So 5 and 5 is 1 point. 5 and 5, that's right there. We know 4 and 2 is 4 and 2 is here. 3 and 1 is here. 2 and 2 is here. And 1 and 5 is here. And it looks like a nice little U shape there. Boom. That's how you graph a parabola. 5 points minimum. You can do 7 points. You can do 2 more points if you really wanted to, but 5 points minimum is required. Let's do this again for example B now. Same way, we are going to start with our middle value, which in this case is my h value. And what is my h value for example B? So just to recap, as I stated earlier, you start with your h value as -1. Your y value for that point is going to be 5, your k value. Then you pick 2 points above, so +1, +2, and then 2 points below. Basically, it's counting. So 0 and 1, and then